Hello friends, myself Ajit Gorakwaki and I am from third year of Electrical Engineering Kopargaon. My teammates are Harshad Shinde, Nikhil Wahadne and Nikhil Mandole. Our group project name is Bidirectional 3-level AC to DC converter charger for vehicle to grid. Now starting with the introduction. Energy storage systems are important component of microgrid as they enable the integration of intermittent renewable energy sources. Electrical vehicle batteries can be utilized as effective storage devices in a microgrid when they are plugged in for charging. Most personal transportation vehicle sit park most most personal transportation vehicles sit parked for about 22 hours each day, during which they represent an ideal asset. EVs could potentially help in microgrid energy management by storing energy when there is surplus. V2G applied to the general power grid faces some challenges such as it is complicated to control, needs large amount of EVs and it is hard to realize in short term. In this scenario, it is easy to implement V2G system in a microgrid. The Society of Automotive Engineers defines three levels of charging for EVs. Level 1. Charging uses plug to connect to the vehicle's onboard charger and a standard household 120 volt outlet. This is the slowest form of the charging and works for those who travel less than 60 km a day and have a night to charge. Now, level 2. Level 2 charging uses a dedicated electrical vehicle supply equipment which is called EVSC at home or at a public station to provide power at 220 volt or 240 volt and up to 30 ampere. Now, the level 3. Level 3 charging is also referred to as DC fast charging. DC fast charging station provide charging power up to 90 kW at 200 by 450 volt, reducing the charging time to 20 to 30 minutes. DC fast charging is preferred for implementation of V2G architecture in microgrid due to the quick power transfer that is required when EVs are utilized for energy storage. Also, the DC bus can be used for integrating renewable generation sources into the system in majority of the previous studies. V2G concept has been applied in the general power grid for services like peak shaving, valley filling, regulation, and spinning reserves. The V2G development in a microgrid facility to support power generation from intermittent renewable sources of energy is still at its infancy. Also, level 1 and level 2 AC charging is utilized for V2G technology in most of the work reported. These AC charging systems are limited by the power rating of onboard charger. An additional issue is that the distribution grid has not been designed for bidirectional energy flow. In this scenario, grid has not been designed for bidirectional energy flow. Need for developing technology viable charging station architecture to facilitate V2G technology in microgrids. This work process a DC quick facilitate V2G technology in microgrid. This work proposes a DC quick charging station to interface EVs also used for integrating a solar photovoltaic PV array into the microgrid. The proposal architecture allows high-power bidirectional charging for EVs, though off-board charger. Effectiveness of the proposed model is evaluated based on MATLAB simulation for both V2J and G2V modes of operation.
Hello everyone, myself Harshad Shinde from group number 13 of feedback and control system. I am going to talk about a simulation of a three-phase bidirectional charger for vehicle to grid and grid to vehicle application. First we insert here a three-phase voltage source. That line to line voltage is 415 volt and frequency of 50 hertz, and it acts as a grid. Then this is a voltage measurement block. It only measures line to ground voltage. Then we insert here a 3 inductor for R phase, Y phase and B phase. The value of inductor is 5 millihenry. Here you can see on screen it is a 5 millihenry. Here you can see the value is 5 millihenry. Then we insert here a capacitor. This is a LC filter and its value is 30 into 10 to the minus of 6 farad, means 30 microfarad. Then same values of inductors are insert here. Then we insert here a active front-end rectifier that converts the AC voltage into DC voltage. Battery requires only a DC voltage, so we have to convert to charge the battery. So we have to convert the voltage AC into DC. Then these are the current measurement block. They are useful for current measurement. Then this is the inverter. Uh, this is a three-level inverter. Uh, this is a bridge of IGBT switch. Here we use a 6 IGBT. The here you can see the resistance in ohm is 0.001 ohm. Then a forward voltage is 1 volt, and a number resistance is 10 raised to 5 ohm. That's it about the IGBT. Then we apply here a gate pulse for each and every IGBT switch, and then here we connect the RC branch across the IGBT bridge. The value of resistance is again 10 raised to minus of 3 ohm, means 1 milli ohm, and the capacitance is 5600 to 10 raised to minus of 6 farad. That's it about this IGBT or inverter that used for DC to AC conversion. During discharging process we require a AC voltage, so we use here a inverter. Then further we connected here the buck boost converter. Here you can see the buck boost converter. We use a MOSFET for this buck boost converter. Here you can see, okay, APT resistance in ohm is 0.1. The internal diode inductance in Henry it's 0. The internal diode resistor is 0.01, and number resistance is again 10 raised to 5. Why we use this buck boost converter here? We use a buck boost converter because during a charging process we require a less voltage. During the charging process, so we use a buck converter during the charging process. We require a more voltage during a discharging process, because we here apply a 415 volt and battery required only a 300 volt. So during the charging process we required we control with the help of control circuit, we active only the buck converter, and during the discharging process we active a boost converter because we required a more voltage during the discharging process. Then further we connected a battery. Let's see. Okay, it is the type of battery is a lithium ion battery. The nominal voltage is 360 volt. The rated capacity is 300 ampere hour, and the initial state of charge is a 50%. Then these are the control circuits of this simulation. The first one is a inverter control circuit. To control the inverter we require this circuit. We use a form and go to blocks here to control the circuit. Then this is a mux multiplexer and demultiplexer we use here. This is current control blocks. This is for buck boost control, and these are the current and voltage control blocks. And here you can see the output of the this simulation. Here are two displays are present for active power and reactive power, and two scopes are connected here for seeing the waveform for during the charging process and discharging process of voltage and current. That's it from my side. Thank you.
Hello everyone, my name is Nikhil Wadne. I will be explaining the further part of the simulation. Let's run the graph. First will be see the V2G mode. Here you can see the active power is positive, which is the battery to the power flow. So the system is working to the V2G mode. Now wait for a few minutes.
Now I will show you the voltage and current waveform. As you see, both the voltage and current waveform is line and phase. This is the DC bus voltage during the V2G operation. Now will be the system is working the G2V mode. That is the charging to the battery make the current here reference the negative. Wait for a few minutes. This is the voltage and current measurement G2V mode. As you see, both the voltage and current out of the phase. This is the bus voltage using G2V mode.
Hello everyone, myself Nikhil Mandwe. I will explain the output waveform of our simulations. This is the waveform when we supply the power from vehicle to the grid in operation mode. The waveform is with respect to voltage and time, and second one is with respect to current and time. This is the three-phase sinusoidal waveform when we supply the power from battery to the grid. At the output we get that it's sinusoidal waveform. Second one is a waveform occurs when we supply the power from vehicle to the grid. At that time the battery get discharged and the waveform will show that the battery discharging times with respect to voltage and current, voltage and time. Charge the vehicle from grid to the battery or grid to the vehicle. This waveform we get. This is the three-phase sinusoidal waveform used to charge the batteries of vehicles, and this is the charging. Second one is the charging waveform of our vehicle batteries with respect to voltage and time. Thank you.